What's happening, guys? Mr. Allen here, and we're about to dive into some hyperbolas. We're going to get some of these basics down from our standard form generic equations here, and then we'll apply it to graphing and all sorts of cool stuff. All right, so a couple things we want to notice. We're still seeing the x minus h and the y minus k. We still got these a squareds and b squareds, right? But there are some differences from what you've seen in an ellipse. So one, that a squared is always at the start, and same the b squared is always the second one. But my x minus h and my y minus k swaps places based on which way it's opening. If it has x minus h squared first, it's opening left and right. If it has y minus k squared first, it's opening up and down. All right. So where do these a and b values go? What do they mean in this particular type of graph? So for the first one here, my a value is that distance from the center to my vertex, my vertices rather. So this would be an a value here, as would that, okay? Now my b value will be for my co-vertice. Let's just say it's gonna be somewhere up, like, maybe that's a little too high right there. Let's go right here. That'll be my b distance right there. And the same would go down here for its co-vertex right there. Whoop, cool. But what about our C value? Because we've seen that C value before, right? That's gonna be where my focus is, or my foci, rather, which would be somewhere around over here. Okay, so that will be the distance from here to there would be my C value, and the same goes right here. That'd be my C value as well. How do I calculate that? Well, this time, it actually is our lovely friend, the same thing as the Pythagorean theorem. A squared plus b squared equals c squared. That's how I'll get that distance, okay? So all of that type of stuff still applies to the one on the right here, except now my a value is going from the center to the vertex, so it's going up and down, right? That's gonna be my a value. My b value will be somewhere, something like this, okay? And then we've got, that's b, and then my foci somewhere in here. Boom. Now there's one other part to our hyperbolas that we are going to use when graphing, and they are asymptotes. Okay, so how do we get these asymptotes? Well, it actually has to do with our a and b value. Okay, and what we'll see a lot of people do is we'll take our pencils and make a dashed box. Okay, a dashed box like this. It'll make a little rectangle going down, connecting my vertices and my co-vertices. Okay, now this equation of the asymptote, our asymptotes are actually going to go through where these corners are, here and here, here and here. So let's do that real quick with our ruler. Boom. All right. Close. And then we'll go ahead and do some dashed lines right through them. And there we are. We've got our asymptotes. And just like with, like, say, rational equations, all right, so the graphs are going to approach that asymptote, not touch or cross that asymptote. All right. Now, my equation of the asymptote for ones that are opening left and right will be this. It'll be y minus k equals, and we'll have b over a as my slope. Notice how it's going up b, and it's going to the right or left, A. And you might be saying, wait, right or left? Hold up. We should have a plus or minus right there, right? Because we're going to have the positive version of the asymptote and the negative version of the asymptote. All right, and then we're going to have x minus h. So this is in point slope form. Most of the time, we use like y equals mx plus b when we're graphing equations of lines. Point slope is really the easiest way to go about these asymptotes, just because the center is not always going to be at 0, 0, so then it can be complicated finding your y-intercept. It's just easier to leave it in point slope form. All right. Now, definitely jot that down, the equations of our asymptotes. It is pluralized because that's plus or minus. There are two different equations that we have chilling right there. Okay, so now for the one on the right here, what's that going to look like as far as our asymptotes are concerned? All right. Well, it's still going to be y minus k and x minus h, but our slope is going to change. If you notice, we're going up A and we're going over B, so it's going to be A over B. Let's jot that down. And there we have it. So our equation is very similar, except for just our slope is going to be switched because we're going up A to the right or to the left B. But other than that, we're all set. Make sure you got those equations of the asymptotes formulas written down, right? We got our a squared plus b squared equals c squared. That's how we're going to find the distance from the center to our foci, right? That's going to be important as well. Other than that, I think we're good. All right, see you.